solve a 9th, 10th and 11th of the exercise problems. So 9th one is, show that this determinant which is equal to x minus y into y minus z into z minus x into xy plus yz plus zx. So as I said that, you just look up with the RHS first. Okay. Anyway, you will consider the LHS and you will apply some property and to get this RHS, right? So in this determinant, in this LHS, so here if you take R2 minus R1 is nothing but this y minus z, you will get it. That is the second factor. Next is R3 implies R3 minus R1, that is z minus x, you will get the third factor. So as I said that, once you just apply only two operations. Okay, if you apply three operations, you may get a determinant value as a 0 sometimes. Okay, so to reduce that complexity, I will just go with the two operations. That is R2 implies R2 minus R1, R3 implies R3 minus R1. So once you apply these two operations for these two rows, you will get the determinant is the first row elements as it is. In the second row it is y minus z, that is R2 minus R1. Next is y square minus x square, R2 minus R1. Next is zx minus yz. Similarly, in the third row, which is z minus x, R3 minus R1, right? Next is z square minus x square, then xy minus yz. So in this, I'll just write it in a simple form. So in this, I can get a first factor, that is x minus y. So here x should be a positive, y should be a negative. In that case, you can take minus as a common. If you take minus as a common, the terms will be, if it is a minus, you will get a plus. If it is a plus, you will get a minus. So I will take a minus as a common. This negative term will be a plus. So positive term will be a negative. The same way here, I will just go with a standard form, that is a square minus b square is nothing but a plus b into a minus b. That is x plus y into x minus y. So in this, you will get y minus x. So for that, I will just take a minus as a common, hence you will get x minus y. So anyway, this factor is a plus. If you interchange the term, it remains the same. Next, in this, I will take a z as a common, remaining is x minus y. So same way, I just applied in a third row. So here z minus x only. So this is z minus x into z plus x. This is the standard form of a square minus b square is nothing but a minus b into a plus b. Next in this, y is a common. If I take y as a common, remaining is x minus z. But I need z minus x. So for that, I took minus as a common, remaining is z minus x. So next is, so in this second row, x minus y is a common in all the three terms. Next in the third row, z minus x, z minus x, z minus x is a common. So I'll take the common factor is x minus y and z minus x in the next step. Okay. So here is, that is, in a second row I'll take x minus y as a common. In a third row, I will take z minus x as a common. So you just write the remaining. So in a first row, which is as it is, x square. Next is yz. In a second row, I took this x minus y as a common. Therefore, the remaining is minus 1. Next is x minus y as a common. Remaining is minus of x plus y. I will just write it directly, that is minus x minus y, because I just multiply this minus for these two terms. Next is, I took this x minus y as a common, remaining is a z. Okay. Next, in a third row, I took this z minus x as a common, remaining is here 1. In this, z minus x is a common, remaining is z plus x. Next, z minus x is a common, remaining is minus y. So next is, I'll just go with the operation which is R3 implies R3 plus R2. Why? Because this will be a 0 and here is z plus x minus x minus y, x and x get cancelled, you will get a second factor, that is y minus z. So for that, I'll just go with the operation, that is R3 in a third row. I'll just apply the operation is third row, I'll just add with the second row. Okay, so here is x minus y into z minus x. We are just applying operation only for the third row. So x, you need to write the first and second row as it is. X square yz. Next minus 1 minus x minus y. Next in this is z. Here is R3 implies R3 plus R2. Plus 1 minus 1 get cancelled, remaining is 0. Next here is z plus x minus y, minus x plus x get cancelled, remaining is z minus y. Z minus y. Next here is minus y and plus z is there. So I just write it in the same format. That is z minus y. Hope this is clear. Now, in a third row, z minus y is a common. I'll take x minus y into z minus x. From a third row, I'll take z minus y is a common factor. As the remaining is here x square yz. Second is minus 1 minus x minus y, and this is z, 0, 1 and a 1. Why these two are 1 means I took z minus y as the common. So next is expanding R3 means while expanding the determinant, you can go with either a column, either a row. So whenever you are expanding any row, if it is a 0, 0, 1 or 1, 0, 0 or 0, 1, 1 is there. So in this case, the simplification will be easy. So for that sake, I am expanding the third row. That means this one. So here you can write x minus y. I'll just write this as y minus z, but y is a negative. If I take a negative as a common in this factor, y will be a plus and z will be a minus. Hope this is clear. Next I'll write the second term as a third, because this is what we need in the RHS. So because of that, I just rewrite this as z minus y as minus of y minus z. Hope this is clear. Now I am expanding this. So here is, while expanding the row, so here the first term is 0. Third row and first column you need to hide it, and the remaining you have to write. But anyway this is a 0, so simplification also you get a 0. So this is a plus and this is a minus and this is a plus. Anyway this is a 0, hence this in a simplification you will get a 0. So I'll just go with the second term. It is a positive and you should take it with a negative one. So your remaining is, you may get confused, so I'll just write it in the determinant form only. So third row and a second column I did. Remaining is your x and here is yz and here is minus 1 and here is a z. This is the second, and a third you should take a plus 1, and here is third row and a third column hide it. Remaining is your x square, and this is minus 1 and this is minus x minus y. Now you just simplify this, you will get the RHS. Yeah, here is minus, this is a minus, so x minus y, next is y minus z, next is z minus x. Now simplifying this, minus 1 of determinant is 2 plus 2 is x into z is xz. In between you should take a minus. So minus 1 into yz is minus yz. It's already minus is there. Minus into minus plus yz it is. Next is plus 1 of. So here is x into minus x minus y. So x into minus x is minus x square. X into minus y is minus, yx. Next is your minus 1 into x square is minus x square. Minus into minus plus x square. So plus x square minus x square get cancelled. So here we can write minus of x minus y, y minus z, z minus x. Simplify this. Pause. Minus x minus y and y minus z, z minus x. So there plus x square minus x square get cancelled. You just multiply this minus for these two terms. You will get minus xz minus yz, and there remaining is minus yx. So now at two more steps, that is x minus y minus z, then z minus x. Next, if I take a minus is common from all these terms, so remaining is, so x, y, I just write it in the harder. So xy plus yz plus zx. Is it clear? Now this minus and this minus will be plus. Hence you can write x minus y into y minus z into z minus x into, this one is xy plus yz plus zx. This is what the required RHS. Hope this is clear. Okay. So we'll just move on to the 10th one. So 10th one is so again the question is saying that prove that the determinant is x plus 4. Next 2x, again 2x, x plus 4, 2x, x plus 4, and the RHS is, we need to prove that 5x plus 4 into 4 minus x whole square. This is a simple one. Okay. I'll just consider the LHS. LHS is x plus 4, 2x. Next is 2x, x plus 4, 2x, x plus 4. You just look up with the RHS. What we need to prove that is 5x plus 4. 5x plus 4. The constant 4 is there, and you need to add it this x as a 5 times. That means you can add r1 plus r2 plus r3 is nothing but x plus 2x will be 3x, 3x plus 2x will be 5x. So hence you will get the RHS of one factor, that is 5x plus 4. So for that I will just do the operation, that is r1 implies. In an r1 I will just add r1 plus r2 plus r3. For the corresponding elements of a r1, you need to add with the corresponding elements of a r2 and a r3. So here you will get x plus 4 plus 2x will be 5x plus 4. 5x plus 4. Next is here 2x plus x will be 3x plus 2x is a 5x plus the constant 4 is 4. So 5x plus 4. Here also you will get the same thing. 2x plus 2x is 4x. 4x plus 1x is 5x. So 5x plus 4. So here we wrote the operation only for the R1. Write the second and the third row as it is. That is 2x, x plus 4, 2x. Next is 2x, x plus 4. Now in the first row you can take 5x plus 4 is a common. So if I take 5x plus 4 is a common, the remaining in a row 1 is 1, 1 and 1. Next two rows are 2x, x plus 4, 2x. Next is 2x, x plus 4. which is what we need in the second factor is like 4 minus x all square is. That means you should get it of 4 minus x into 4 minus x. So in that case, I'll just add it these two columns. That is C2 implies C2 minus C1 is nothing but x minus 2x will be minus x plus 4. That can be written as 4 minus x. Okay, so I'll just do the operation, which is okay here. C2 implies C2 minus C1 for this C2. Next is C3 implies C3 minus C1 again. C3 minus C1. You just write it. Now 5x plus 4. Now we just wrote it the operation only for the second column and a third column. We just write the first column as it is 1, 2x and a 2x. So second column will be C2 minus C1. 1 minus 1 is a 0. Next x plus 4 minus 2x will be minus x plus 4 it is. Okay. Next 2x minus 2x is 0. I'll go with the third column operation. 1 minus 1 is again a 0. 2x minus 2x is again a 0. Next is x plus 4 minus 2x is minus x plus 4. So now what I'll do is I'll take a common from the second column of minus x plus 4. In a third column I just take minus x plus 4 is a common. So there 5x plus 4. Okay. I'll take this minus x plus 4 is a common from the second column. So I can write this as 4 minus x. Okay. It doesn't change. So I just wrote it the positive term first and negative term second. Next is here also in the third column I'll take 4 minus x is a common. 4 minus x is common. So remaining determinant is 1, 0, 0. Here is 2x and a 2x. I took this as a common, hence here remaining is a 1 and this is a 0. So 0, 0. I took this as a common, hence the remaining is a 1. Now you just expand it. Expanding first row. First row is 1, 0, 0. More number of a 0 in either in any one row, either in any one column. We just expand that determinant. Then the simplification will be easy. So therefore, in these three cases, in these three rows, so this one is a simple. More number of zeros in a first row. So I am just expanding the first row. So here is 5x plus 4. I can write this 4 minus x into 4 minus x is 4 minus x all square. 4 minus x all square. If you expand this one, 1 into first row, first column I did. So remaining is these 4 elements. So first diagonal is 1 into 1. 1 into 1 minus 0. The remaining will be 2 terms will be vanished. Why? Because this is a 0. 0 into anything is 0. Okay. Even this is also 0. 5x plus 4 into 4 minus x all square. 1 into 1 will be 1. Therefore, this is 5x plus 4 into 4 minus x all square, and this is what RHS, that is the required one. Hope this is clear. Okay. In a 10th one, second question is there. Okay, sub question is there. So again, that is also the same type. Okay, you just try that one. I'll go with the last problem, that is 11th one. Again, that is also a simple one, important for the main exam. So 11th one is, so in this question also 2 are there. So both the questions are important for the main exam. I'll do first one, a second one you guys do it, because which is exactly same as what I do the problem. Okay. So here is 11. First one is a minus b minus c, 2a, 2b, B minus C minus A, then 2B, 2C, 2C, C minus A minus B, and this we need to prove that A plus B plus C whole cube it is. Okay, so here it is. We need to get the RHS is A plus B plus C, whatever the power, you just leave it. So we need to get this one, A plus B plus C. So here is, you can go with R1 plus R2 plus R3. Why? Because here A is there, minus B plus 2B plus B. Minus C plus 2C is again plus C. That means A plus B plus C you will get. Again here also you will get A plus B plus C. Here also you will get A plus B plus C. So I will just go with the operation, that is R1 implies R1 plus R2 plus R3. In a first row, for the corresponding elements, you have to add both the second row and a third row corresponding elements. Then you will get A minus B minus C plus 2B plus 2C. You will get A plus B plus C. You just check with that. Next is 2A plus B minus C minus A plus 2C. Again you will get A plus B plus C. So for this 2A plus 2B plus C minus A minus B, you will get again the same A plus B plus C. You want to just cross verify. So here I wrote it only the operation 1. That means the second and the third row you need to write as it is, which is 2B, B minus C minus A, again 2B, 2C, 2C, C minus A minus B. So what you do, in a first row A plus B plus C is a common. I just take A plus B plus C is a common. That means in a first row remaining is 1, 1 and a 1. In the second row 2B, B minus C minus A, 2B, and here is 2C, 2C, C minus A minus B. Now I will do a two more operation which is same as the previous problem, that is C2 implies C2 minus C1. That means here you will get B minus C minus A plus 2B, you will get minus B minus C minus A. In that case you can take minus as a common, you will get again A plus B plus C here. So here also you will get A plus B plus C. So in that case you can take A plus B plus C as a common, again A plus B plus C as a common. That means you will get the RHS. So now I will do the operation which is C2 implies C2 minus C1. Next is C3 implies C3 minus C1. We can write that as A plus B plus C. So here I just wrote it the second and a third column operation. That means the first column you need to write as it is. So 1, 2B and a 2C. C2 minus C1. 1 minus 1 is 0. Next B minus C minus A minus 2B is nothing but you will get minus B minus C minus A. You can check it. 2C minus 2C is 0. Next C3 minus C1, 1 minus 1 is 0. 2B minus 2B is 0. Next C minus A minus B minus 2C, you will get plus C minus 2C is nothing but negative C. Minus C minus A minus B. Okay. So A plus B plus C. So I will just write it in a simple form. 1, 2B, 2C, 0. All the three terms having a negative sign. If I take negative as a common, then all the three terms will be plus. So I just write it A plus B plus C this. And this is 0, 0, 0. Again the same thing, I take minus as a common. Remaining is A plus B plus C. Now you can take A plus B plus C as a common from the C2 as well as the C3. So if I take a plus b plus c. I'll take a plus b plus c is common from the second column. Again I'll take a plus b plus c is a common from third column. And the remaining determinant is, here is 1, 0, 0. Next here is 2b. This one is, I took this whole term is a common. Remaining is minus 1, 0. 2c, 0, minus 1. Now I'll just expand. I'll expand the R1. 1, 0, 0 is there. That means the second and a third term will be a 0. You need to write only the first term, which is a plus b plus c into a plus b plus c into a plus b plus c is nothing but a plus b plus c whole cube it is. Okay, here we can write 1 into, that is first row, first column I did, remaining is only these 4 elements, minus 1 into minus 1 minus 0. This is by expanding R1. Hope this is understood. Now minus 1 into minus 1 is plus 1. So 1 into anything is, here this term is nothing but a plus b plus c whole cube into 1, or you can write a plus b plus c whole cube. This is equal to required RHS, an important one for the exam. Again in 11th question, one more question is there, exactly the same type, and you can apply the same operation also, you will get the same answer. Okay, hope this is understood. Thank you guys, and remaining 3 questions is there, I'll do it in the